Hey, I'm Darryl Fossil. I'm the engineer here at Mallett, and want to share some stuff with you this last Monday of this year. And so I titled it Secret Recipes and Sausage Making. So whenever I stand up here and give these talks every week, I want to be informative without giving away my secret recipe for how we design these buildings. And I don't want to bore you with the sausage making or give you too much detail. So that's what that's about. So, when it comes to secret recipe, we all know about the secret recipe of Coca-Cola that's locked tight in a vault. I thought that was a really cool picture. And Tyler says that's a real thing. And then, of course, you have the KFC secret recipe, which somebody put this on the internet, so it must be true. I have a story to tell about the Kentucky Fried Chicken. So this would have been about 1966, maybe 1967, something like that. And we lived in Huntsville, Alabama, and my grandmother lived in Bogalusa, Louisiana. And she caught the train and from Louisiana up to Alabama, and we went to Birmingham to pick her up. And after we picked her up at the train station, I was a little boy, we went to eat at Kentucky Fried Chicken. And I know you can't imagine this, but back in 1967, 1969, all in that time, there were very few fast food restaurants. That was kind of the beginning of the fast food era. And I never will. I have a distinct memory of eating that chicken and drinking a Mountain Dew. And I just thought that was the most magical thing ever. I can still taste it. So, but anyway, I don't want to give away my secret recipe to my fried chicken. And then I don't want to get into the sausage making. And I don't know if you've heard this quote or not, or how the sausage is made. And it comes from a quote that laws are like sausages. It's better not to see them being made. And I would have, I've given you this beautiful picture of some sausage, Louisiana sausages, and some bell peppers and onions. And I'm not going to show you pictures of sausage being made because that'd be really gross. And so now to get into, I guess, the sausage making part. I've showed you this before, but this is very critical in the criteria, the requirements that I use in designing these Mallett buildings, and that is the rules for deflection. And in the International Building Code in Chapter 16, it says that for structural roofing and siding made of formed metal sheets, the total load deflection shall not exceed L/60. And then it says, for secondary wall members supporting formed metal siding, the design wind load deflection shall not exceed L/90. So you take, for the metal sheathing, the metal sheathing spans 30 inches. And so the deflection in that 30-inch span can only be 30 inches over 90, which is a third of an inch. And then the deflection for the secondary wall members supporting that, our wall members, our purlins, our girts, wall girts, span from post to post, which our posts are spaced at 10 feet, 9 feet, 8 feet, depending on the wind load. And so that's one of the keys meeting this criteria is one of the keys to designing these, properly designing the Mallett building. And then another thing, it's in the sausage making, this this odd looking slide here is kind of the basics of designing a beam. This is the beam, and this is the span between the supports, and this is the load, and that's a beam that's got two equal spans, and then this is a beam that has one equal span, and then this is a beam that rather than having a distributed load, it's got a concentrated load in the middle. Now, those three things are really the meat of how we design the Mallett Buildings, is using those three formulas, and that's enough said about that. So, if you look at our Mallett building, and especially in this photo, this drawing is 3D perspective, you can see that our building is just a series of beams running running perpendicular parallel, and so we designed that based using those formulas. And then here, just another picture of it here. If you look at this, and then you go back, you see that looks very similar to that. And so that's how we design our buildings. And so the thing is, if you look at, when you see this, you just see a cross-section of the building. But when I see this, and when I think about it, I see the design process, because someone that taught me a lot about engineering said that you build a building from the ground up, and you design a building from the top down. And so what does that mean? Well, the first thing in designing this structure, we have to make sure that the wind doesn't pull the sheeting off of these roof purlins. And then the second thing we have to make sure about is that the roof purlin stays connected to the roof truss. And then the next thing we have to do is the roof truss has to be properly designed for the proper wind load. And then the next thing we have to do is we have to make sure that the roof truss is connected to the post or the nub. And then the next thing we have to do is to make sure that the wall panel doesn't blow off, doesn't get sucked off the building. And then the next thing is we have to make sure that the wall girt stays connected to the post and doesn't deflect excessively. And then the next thing we have to do is make sure that our post is properly designed and is in the ground. And then the next thing we have to make sure that the slab is properly constructed. And so you see it's just one part after one part after one part. And that's as specific as I will ever get when it comes to designing my building and how we do these buildings. But it's good to know that somebody here at Mallett is designing every part and piece of this building. And, the proof, just like, with sausage or just like the chicken or just like the Coke, the proof is in the product. And, I'm sure you say, well, I don't know if you say, you probably say, I don't care what's in Coke. I love it. It tastes great. I don't care what's in the Kentucky Fried Chicken because it tastes great. I don't want to know about how the sausages are made. I just want to eat it. Well, the proof is in the product. Well, as we say over and over again, because Mr. Lee has been building these buildings for so long, we have the proof of the product. And we have a great product that has been able to withstand these storms that I talk about all the time, these design wind loads, these freak wind events, these tornadoes and straight line winds and stuff like that. And so not only is it a great product from the standpoint that it stands the rigorous requirements of the International Building Code, but it's a great product because it's stand the test of time and it's stood the actual events that have happened. So that's today, and no corny jokes today. I'll just say, see you next year.